This week saw the final launch of the SpaceX Starship as we know it, and it's pretty hard to imagine a more perfect send-off for the first era of Starbase. After years of spectacular explosions, fireballs lighting up the Texas coast, and what SpaceX euphemistically calls rapid unscheduled disassemblies, Flight 11 delivered something we've been waiting for, the closest thing to perfection that a Starship test has ever offered us. But here's the twist. The biggest story of the day isn't what happened on Flight 11. It's the promise of what will come next. Because while this flight was nearly flawless, it was also a funeral. The last goodbye to the design that got us here. The final performance of Starship version 2, before it's replaced by something far more powerful. So let's dive into Flight 11, a mission that was both a triumph and a eulogy, and then reveal what SpaceX has been building in secret that will take humanity to the Moon and Mars. All of this begins with a previously flown Super Heavy booster. And that detail alone is revolutionary. This is the same rocket we saw launch on Flight 8 back in March 2025. After that flight, the booster was caught by the mechanical arms, those massive chopsticks that grabbed it out of the sky, then returned to the Star Factory for some cleanup and refurbishing. The refurbishment included replacing some of the engines, but here's the key. We still have 24 of the original Raptor engines from Flight 8 returning for Flight 11. These engines have already been to space once. They've experienced the violence of launch, the extreme temperatures of atmospheric re-entry, and the precision required for a controlled landing. And now they're doing it again. This is the proof that booster reusability actually works, not just in theory, but in practice. This is the holy grail of spaceflight economics, the thing that will make space travel affordable, the breakthrough that will turn rockets from disposable billion-dollar missiles into reusable aircraft. And on Flight 11, those 24 battle-tested Raptor engines performed beautifully. By now, everyone knows what a successful Starship launch looks like. And this one was no different. Think about that statement for a moment. Everyone knows what a successful Starship launch looks like. That would have been impossible to say just 2 years ago. Back then, every launch was a nail-biter. Every test ended in an explosion. And success was defined as it flew for a few minutes before blowing up. But Flight 11, a beautiful ascent into a clear blue evening sky. The 33 Raptor engines ignited in perfect synchronization, lifting the massive rocket off the pad. The hot stage separation came exactly on schedule. The upper stage's engines firing while still attached to the booster, pushing them apart in a controlled explosion of thrust. Then the booster executed its flip maneuver and began the journey back to the surface of Earth. This is routine excellence. This is mastery. This is what success looks like when you've learned from failure after failure after failure. But SpaceX doesn't do routine for long. Even in their moment of triumph, they were experimenting. This time around, SpaceX had a new test for their booster landing burn. Just like the 2 previous flights, this one was not going to be a tower catch. Instead, they were bringing the rocket down over the water in the Gulf of Mexico. And that gave them the freedom to try something new without worrying about any consequences. Normally, the landing procedure starts with 13 engines firing to slow the massive booster down, then drops to just 3 engines for the final touchdown. But on Flight 11, they tried something different. 13 engines, then down to 5, then finally to 3 engines, right at the very end of the landing. Why does this matter? SpaceX says this is a test run of the new procedure for the next-generation booster V3. It's basically going to use a little bit less fuel for the landing burn, which means there's more fuel available for liftoff. More fuel for liftoff means more payload capacity. More payload capacity means we can send heavier things to orbit, or send the same things further into space. This is continuous innovation. This is SpaceX's philosophy. Even when you succeed, find a way to improve. And the new landing sequence worked flawlessly. The booster came down over the water, executing the multi-stage engine burn perfectly before splashing down in a controlled impact. Meanwhile, in space, the Starship upper stage was making its way flawlessly into a suborbital trajectory around the globe. All we're really looking for at this stage is simple. The ship remains in control the entire time, and nothing blows up. That might sound like a low bar, but remember, previous flights have seen ships tumbling out of control, heat shields failing, and explosions during re-entry. Not only did Starship maintain perfect control through its coasting phase, it also gave us a pretty amazing demonstration of what those wing flaps are capable of when they don't end up melting away during re-entry. At around T+58 minutes into the flight, at an altitude of 50 kilometers, something unprecedented happened. Starship began its first planned dynamic banking maneuver. That's essentially their first attempt at changing course in mid-flight. Instead of letting the ship come down naturally in a straight arc, just following the ballistic trajectory that physics dictates, they were actively steering. The ship banked and turned, tracing a kind of semicircular path as it descended through the atmosphere. This is a critical test for future landing attempts, when the ship is going to return to its own launch site. Here's why. When Starship launches from Starbase, Texas, it heads out over the Gulf of Mexico, then continues east. But to return and land at the same tower it launched from, it needs to reverse course. It needs to gradually steer itself back from over Mexico, arc through the sky, and approach Starbase from a completely different direction. Then, just above the ground, moving at hundreds of miles per hour, the ship needs to make a final twist maneuver to align itself perfectly with the tower and the waiting catch arms. This is like parallel parking a school bus while falling from space, at supersonic speeds, on fire. And Flight 11 was the first time they practiced these maneuvers for real. We can see the ship practice the final alignment turn at T+1 hour and 5 minutes into the flight. The Starship spins itself around about 180 degrees, flipping its orientation in space. Then it executes the downward flip, the belly flop to vertical maneuver that's become SpaceX's signature move. The ship rotates from horizontal to vertical, pointing its engines down toward the ocean below. And then, with perfect timing, it ignites those engines for the landing burn. Even with all of that steering, all of that changing direction in mid-flight, all of those complex maneuvers stacked on top of each other, the ship somehow still manages to land right on target beside the floating buoy camera stationed in the Gulf. We watch it splash down lightly, a gentle touchdown in the water. Then it tips over slowly, like a falling tree, and explodes in a satisfying fireball as the remaining fuel ignites. But here's what makes this moment bittersweet. That is the last time that a Starship launch will ever look like that. This was the final performance of the V2 design. The last flight of this era. The end of the beginning. Flight 12 is where the new chapter begins, and that means everything, from the ship to the booster to the launch pad itself, will be totally different next time around. The next iteration of the Super Heavy booster is going to bring a totally new look and a lot more power to the table. Starting at the base of the new Super Heavy, it's still going to have 33 engines, but these will be the Raptor V3. And the Raptor 3 is a completely different beast. The new engines come with significantly more power, an increase from 230 tons of thrust up to 280 tons per engine. Do the math. 33 engines times 280 tons equals over 9,200 tons of thrust at liftoff. That's more thrust than the Saturn V rocket that took us to the moon. That's more thrust than the Soviet N-1. That's more thrust than anything humanity has ever built. But more importantly than raw power, we're getting a much more simplified engine design from Raptor 3. Look at the side-by-side comparison. There's a dramatic reduction in visible parts. Basically, every hose, every wire, every external component from Raptor V2 has been brought inside the engine casing. This isn't just aesthetically cleaner, it's functionally superior. It's easier to manufacture, which means SpaceX can build them faster and cheaper. It's more reliable in flight because there's less stuff being exposed to the extreme conditions during launch and re-entry. Fewer parts means fewer things that can fail. SpaceX says that the Raptor 3 testing phase is now complete, and the first flight-ready engines are rolling off the production line as we speak. Moving up the booster, the overall length is going to be stretched out a bit to accommodate larger fuel tanks to feed those thirstier, more powerful engines. That new fuel system includes this absolutely massive transfer tube that allows liquid methane to flow down from the top of the booster all the way to the engine bay at the bottom. For scale here, that new transfer tube alone is about the size of a Falcon 9 booster. A rocket within a rocket. It's like SpaceX looked at their most successful rocket, the Falcon 9, which has dominated the launch industry for years, and said, "Let's use that as a fuel pipe." And it's at the top of the new Super Heavy that things get really interesting. The first change you probably notice is that we've gone from 4 grid fins down to just 3, and they've repositioned the remaining fins into this distinctive T-shaped pattern instead of the X pattern we're used to. It looks like their main reason for doing this was to integrate the catch pin, the hard point where the chopstick arms grab the booster, directly into the structure of the fin itself, rather than having it as a separate component. To accomplish that engineering challenge, each grid fin has been beefed up by around 50%, making them significantly bigger and stronger than before. And apparently, that gave SpaceX enough confidence to remove one fin entirely. We know that deleting parts is Elon Musk's favorite design philosophy. He's famous for saying, "The best part is no part." Every component you remove is weight you don't have to lift, complexity you don't have to manage, and a potential failure point you've eliminated. So now we're going to find out whether they end up having to put that 4th fin back or not. My guess? It's gone for good. Then, above the grid fins, there's something totally new for the Super Heavy: an integrated hot stage connection. For every launch since Flight 2, SpaceX has used hot stage separation to push the ship away from the booster. The concept is brilliant. Instead of using explosive bolts or springs to separate the stages, the upper stage just fires its engines while still attached. The thrust pushes them apart. And it's actually more fuel efficient than traditional staging methods. It's always worked great, but it always required an interstage adapter to be placed between the booster and the ship. This adapter protected the booster's fuel tank from the engine flames and allowed the exhaust gases to escape out to the sides through vents. That interstage adapter might seem like a small thing, but it weighed about 10 metric tons, and it had to be dropped into the ocean after every separation, like a gigantic piece of space litter. For a company obsessed with reusability, throwing away 10 tons of hardware every single flight was not a sustainable long-term solution. That's why the new booster has this innovative triangle pattern of support beams at the top that provides a lot more open space to vent the exhaust gases. And in the middle of those beams is a new reinforced dome section. That dome is actually the top of the methane fuel tank. And SpaceX has welded on these extra layers of steel in strategic locations to protect the tank from direct engine fire during the hot stage. Instead of using a separate adapter that gets thrown away, they've built the protection directly into the booster itself. It's more elegant, it's lighter, it's reusable, it's sustainable. This is engineering evolution at its finest. Moving up to the Starship itself, the V3 is going to look pretty similar to the existing design on the outside, but on the inside, it's getting a complete transformation. The current V2 ship is probably best known for having some reliability issues. Let's be honest, most of them experienced a rapid, unscheduled disassembly of one kind or another. And as far as anyone can tell, each one of those failures was able to shed light on a different issue with the overall design. SpaceX has spent this entire year finding problems, fixing them, then finding new problems, and repeating that process over and over again. Up until Flight 10, which was mostly successful, but we did see the ship get absolutely rocked by an explosion in the engine compartment that shredded 2 of the rear control flaps prior to re-entry. So after learning from all of those expensive, explosive mistakes, the engineers at Starbase have completely redesigned the fuel delivery system for Starship V3. Every pipe, every valve, every connection point has been rethought based on real-world data from flights that didn't go according to plan. This rocket is also getting the upgraded Raptor 3 engine, which should prove to be dramatically more reliable than the Raptor 2. With all of that combined, the new fuel system, the new engines, the lessons learned from a year of iterative testing, this new Starship Super Heavy stack is going to be capable of deploying somewhere between 100 and 150 tons of payload into low Earth orbit. Let that sink in. 100 to 150 tons. That's going to put it on par with the capability of the legendary Saturn V moon rocket from the Apollo program. The rocket that took humans to another world. Only Starship will also be fully reusable. Something that would have been considered physically impossible, economically insane, and borderline magical back in the Apollo days. And speaking to that reusability, SpaceX gave us the most detailed preview yet of what orbital docking and fuel transfer is going to look like in practice. The exterior of the V3 ship is going to be fitted with new docking adapters on the back side, opposite the heat shield tiles. And then it looks like there will be 2 kinds of Starship, one with male adapters and one with female receptacles, or one built for sending fuel and one for receiving it, whichever terminology you prefer. After making that connection in orbit, 2 starships docked together hundreds of miles above Earth, they're going to transfer liquid methane and liquid oxygen between them. This will allow the receiving ship to completely refill its tanks, which will allow it to fly higher into space and reach destinations that would otherwise be impossible. Want to go to the moon? Launch 1 Starship, then launch 5 or 6 more as fuel tankers, dock them all together in orbit, transfer the fuel, and suddenly you have enough propellant to escape Earth's gravity and coast all the way to lunar orbit. Want to go to Mars? Same concept, just more tanker flights. This is the key that unlocks the solar system. SpaceX has said that this new Starship V3 is not the final design. There will be V4, V5, and beyond. But V3 will be the one that matters most, because V3 will be the one that first lands on the Moon and Mars, or at least attempts to land. We'll see how that goes. And supporting all of this evolution will be a new and improved Starship launch pad and catch tower, often referred to as Stage 0 in SpaceX terminology, the critical infrastructure that makes everything else possible. Flight 11 will be the final launch from Tower 1, the original Mechazilla, and it will be the last time that SpaceX uses their upside-down showerhead flame diverter system, that bizarre-looking steel structure that redirects the engine exhaust during launch. Tower 2, which is already under construction, has a more traditional approach, a flame trench and water deluge system at its base similar to what you'd see underneath a Falcon 9 or the Space Shuttle. Proven technology, scaled up to handle the massive thrust of Starship. The tower itself will be taller and stronger than before, built to handle the increased mass and power of the V3 vehicles. But interestingly, the chopstick arms, the mechanical catch system, will actually be much shorter than the original Mechazilla. The reason for that is pretty simple. Smaller arms can move faster and will be more stable when they're grabbing a falling rocket out of the sky. When SpaceX built the first set of arms, they'd never caught a rocket before, so they didn't know exactly how much surface area they would need. They built them long, just to be safe. Turns out, not very much. The booster barely needs any contact area to be caught successfully. So now they're building smarter, lighter, faster, more precise. This is SpaceX's iterative philosophy applied to infrastructure. Build it, test it, learn from it, then rebuild it better. So that's the dramatic story behind SpaceX's 11th Starship test flight. A nearly perfect mission that served as both a celebration and a farewell. Flight 11 proved that the V2 design works. Booster reusability is real. Flight control is mastered. The technology is sound. But it also revealed the limits of that design and showcased the revolutionary improvements that are coming next. Raptor 3 engines with 20% more thrust and radically simplified construction. 3 grid fins instead of 4, with integrated catch hardware. The elimination of the 10-ton interstage adapter. Completely redesigned fuel systems learning from every failure. Orbital docking for fuel transfer. And payload capacity matching the mighty Saturn V, but fully, completely, economically reusable. This gives us a lot to look forward to, which is great news. It means that the next chapter for Starship will bring new and exciting challenges, new achievements, and new possibilities all over again. The era of testing is ending. The era of operational spaceflight to the Moon and Mars is beginning, so stay tuned. The best is yet to come.